So we are ready to go with the workshop now. So before we start, I just wanted to ask a very fundamental question on what is the purpose of doing a modeling? This workshop is about modeling of an electric vehicle using a software tool, which is very popular in the industry. It's MATLAB and Simulink. But guys, do you have any idea about why do we do a simulation or what is a mathematical model? So my question is, I repeat the question, why do we do the system level modeling, or what is the purpose of developing a mathematical model and do a simulation? So Ganesh is replying, testing before actual demonstration. Okay, I agree with you, Ganesh. Neeraj Lakshmikant is replying, okay, it's cost effective. Uh, exactly. The physical testing of product is expensive. Okay. To see any kind of limitations or failures. Okay. Okay. Parth is replying to no errors. Okay. Modeling gives us an idea how the product will perform. Okay. Yeah. So great. So I hope all of you guys are having very fundamental idea on what is modeling and why do we actually need this, right? But even though from the audience or to get you the better clarity, let me explain you what is mathematical modeling and why we do the simulation, right? So it's not only related to electric vehicle, but almost all the systems which are engineered, which are designed nowadays, they go through a systematic approach, which is mathematical modeling and simulation, right? So as you guys replied, mathematical models are most suitable for initial experiments, right? So if we plan to develop some product, or if we plan to develop some engineering system where we want to just analyze why what is going to happen, right? And how to start with, right? Or which choice is better, how to make important engineering decisions. So all these things are very much relying on doing a mathematical simulation. And guys, please also be informed that it's not the mathematical modeling but be the first step. It's actually the pen and paper, which is going to be the first step for any engineering project. So what you basically do, you once you figure out what are the specification of your product or what are the specification of the project which you want to carry out, the very first task is to make a paper design. So that's how engineers work in the industry. And once the initial paper design is done, then the modeling and system engineers will work upon this. Now, yeah, another reason for simulation is actual system realization, right? So realizing an actual system, it may be costly and time consuming, right? So you may just need to do a proof of concept of your idea, right? Or you may just wanted to understand what will happen if you do this kind of changes, right? So in order to understand this, a simulation is must. So most of the engineering systems, whether it's mechanical, electrical, automobile, or anything, they are actually simulated in a computer, then made available, right? Or then actually designed. Now, guys, another question, which is going to be a quick one, where uh, can anyone know how does a simulation work? Guys, please reply with we have understood that why a simulation is required, right? So why is answered. Now, the next question is how. How does a simulation work? Yeah, so many replies from you guys. Thanks a lot. By solving the governing equations applied, okay, evaluating the boundary conditions, numerical method. Yeah, thanks a lot, guys. So basically, a simulation is nothing but creating a virtual reality, right, in a software environment. So by simulation, we mean that we mathematically model a system in such a way that its behavior is exactly same as a physical system or actual system. But how does a simulation work? So The simulation is going to be first dependent on the physical experiment or the practical, right? So when you say that we are doing it in simulation, what is the purpose of doing a simulation? We want to try to understand or try to gauge what will happen in reality, right? So the simulations has to be real, right? Or we need to make simulations so that they represent the real world situation. So the simulation should be dependent on real life situations or physical experiments, right? So from physical experiments or the practical results which are done by physicists or scientists, they are going to develop governing equations, right? So few of you guys have already replied. There are governing equations, or we can say the theory, right? So the governing equation or theory is going to work behind any of the simulation, right? So please keep this in mind. There will be very fundamental equations working behind the software, right? So in the graphical user interface, you may think like there is a gear system, or there is an engine, or maybe some battery and a motor systems, but in the background, for a computer, everything is going to be a equation. And from this equation, the mathematical model is going to be developed, right? And that is called nothing but a simulation, right? So why simulation, how simulation? I hope you guys it's more clear now. What you can expect in this workshop, let me quickly guide through that. We are going to step by step create a simulation for an electric vehicle in MATLAB and Simulink, right? So at the end of this workshop, you are going to learn how exactly we can do the simulation of an electric vehicle using MATLAB and Simulink, right? Now, what are my objectives, right? So before doing any exercise or before doing any kind of engineering system modeling, we need to set the objectives, right? So my objectives behind making a MATLAB and Simulink model of an electric vehicle is to make the most simple and low runtime vehicle model. And I'm going to use individual component blocks, right? So my first objective is to make a very simple model so that it's going to be easy for me to understand it and to do the experiment with. At the same time, I want this to be a low runtime vehicle model. What do you mean by low runtime vehicle? So, guys, how do you drive your vehicle? So probably if you travel in a uh, city, like let's say 20 kilometers is your travel distance, and you are taking around, let's say, 45 minutes, right? Now 45 minutes and 20 kilometers is your actual condition of a trip, right? Now when you are going to model this, you should not wait for 45 minutes in front of the computer to finish the simulation. Does it make sense, right? So if you are going to wait for 45 minutes in front of a computer, you are actually wasting too much of your time, right? Or simulation is running at very low speed. So the simulation should run at a faster pace, and the overall runtime should be also less, right? So you should be able to finish, let's say, 30 minutes of a simulation in maybe 2 to 3 minutes of time, right? Which is on the computer time, right? So this is one of the objective which I have set for my model. The second objective is to run the individual modules of the vehicle and integrated. So these are my steps. So initially I'm going to make a model of the vehicle body and maybe the chassis, and then I'm going to integrate motor, battery, and controller and all other parameters step by step. And while doing that, I can actually individually test them without connecting them to other components, right? So these are my steps. Now, what basically we want to get out of a simulation? So we want to get performance parameters, like what should be the speed of the vehicle, what should be the state of charge of the battery, and what is the value of the current, or what is the nature of the current being drawn from the battery for various driving conditions, right? Now my objective is also to play with the motor power, the vehicle body, and the vehicle related parameters, which are like rolling resistance, aerodynamic drag, and the weight of the vehicle. So I want to play with, right? What is the meaning of to play with? I need to juggle the numbers where I have a motor power of, let's say, 10 kilowatt, and I want to check out whether for this vehicle body and the weight and the aerodynamic resistance, uh, is the 10 kilowatt power enough for running this vehicle or not, right? And the last objective is to know the MATLAB models and configure to match with the actual vehicle, right? So now the last objective is to make it more realistic. So let's start, guys, and let me explain you what I'm going to do exactly inside the MATLAB, right? If any of you are not aware of MATLAB and Simulink, it's totally fine. You are going to see the MATLAB window for the first time today. That is also okay. But if you have a concept in your mind, you will be able to follow any tool, right? So I'm going to explain you what I'm going to do in the MATLAB and Simulink. So I'm going to create this block diagram. Now, what is this block diagram? This block diagram is an electric vehicle block diagram. So first, I'm going to take a vehicle body. What is a vehicle body? Vehicle body is nothing but, let's say we want to make a car and it has four wheels and a chassis and the vehicle body mounted on the chassis, right? So the first model I'm going to make is going to be a vehicle body. Now that vehicle body will be connected through the transmission gear system to a permanent magnet DC motor, right? So I'm going to use a permanent magnet DC motor, which is the most simple motor to be followed, right? If you are doing your first experiments. Now, how do we give the power to this motor? Now, we usually do not have the AC supply or grid supply running with the vehicle, right? So vehicles energy storage is on board, or we can say it's a portable power. So a battery is going to actually give electrical power to the motor, and motor is going to convert this electrical power to mechanical, and the vehicle is going to run, right? So that's what we want to simulate. So we are going to have now a battery system where I'm going to have a charge, discharge, and state of charge related calculation for the battery. Now, what will happen if I connect this battery directly to the motor? Well, there won't be any control, right? And the vehicle is going to run at a constant speed, which is decided by the motor characteristics and the vehicle characteristics. So in order to control the speed of the motor and therefore the vehicle, we will require a motor controller. A motor controller is nothing but a power converter. In this case, I'm going to use H bridge with regenerative braking. So whenever the vehicle is decelerating, the kinetic energy of the vehicle will be given back to the battery when the motor is acting as a generator. So this is a power converter, and this is going to be the normal direction of power flow when the vehicle is running. So battery is going to be feeding the power to the power converter. Power converter will be giving the controlled voltage and current to the motor, and therefore our vehicle is going to be controlled. Now, these blocks are enough, I think, right? Or do you think anything is missing? How do we perform a simulation? Are these four blocks enough? No, Neeraj is saying no. We need to include? Mayank is saying power GUI. Okay, we need to include. Okay, no need for a driver. Okay, feedback. Yes, a dynamo. Okay, probably we are not going to test here for a dynamo, but important thing is a feedback, right? Now, what is the way in which we want to run a simulation, right? So let's move ahead, guys. So I'm not going to check out your replies now. So what is missing here in this block diagram is what speed we want to run the vehicle, right? Who is going to sit on the steering or on the driver's seat, and how we are going to run the simulation, right? So for doing the simulation, we should know what are the conditions which we will be giving as a reference. So we need to give some reference to the system in such a way that we want to run this simulation for, right? So in under what situation we want to run this vehicle, so that situations are nothing but a drive cycle. So drive cycle is going to be given to a driver controller, and that driver controller commands will be given to a power converter. So what is the meaning of a drive cycle over here? The drive cycle over here, these two blocks together are going to make a reference for our simulation, right? So we are going to define it well in advance that this is the pattern or this is the way in which we want to run our vehicle, right? I hope this is going to be clear with you. And let's move further and let's step by step make uh, the Simulink model for a vehicle. Okay, so these are the things I'm going to use for Simulink model, right? So these are the Simscape blocks, and it also includes powertrain block set and some of the blocks from powertrain block set, and there are Simulink blocks, right? So what we are going to do, we are going to use tires, vehicle body, gears, inertia. We are going to use a longitudinal driver, then electrical parameters, and the drive cycle resource. We'll be also using the scope to display the output, some constant, some division, some display, and a signal builder block. Right. So what basically I'm going to do, so my first step, as you can see in this image, is to create a chassis of a vehicle system. Right. So once I'm taking 4 tires and I'm connecting them on a chassis like this, now I can fit a vehicle body on this, and I can put the motor through the transmission system. I can put the battery and an H bridge controller, right? So these are the fundamental building blocks which I'm going to use. If you are not aware of MATLAB and Simulink, it's totally fine. What we are going to do is we are going to have a block of tire, right? So in the Simulink environment, and that block of tire will be exactly similar to how does an automotive tire behaves, right? So those tire equations are built into that block, and the same applies for rest of the blocks as well. So the next image is going to be a total car, right? Where you can see here where we have the battery and the motor and the steering and some space for a driver, and the vehicle body is also mounted on it, right? So this is a vehicle model. Now we have some other blocks apart from this. Which are the other blocks which you are not able to see over here? Is a driver, right? So there is going to be a driver inside, and we are going to say driver that this is how you should run your vehicle, right? So a driver with predefined information is going to be sitting inside the vehicle, and that is what we are going to simulate. I hope this is clear to you all, guys. Okay, so now let me show you my Simulink window, and let's start building blocks and model for an electric vehicle. So I hope, guys, you are able to see my Simulink window. You can quickly reply in your chat box whether you are able to see it or not. Now, okay, yeah. So now, very first thing in the Simulink window is we are going to start with the tire. So I'm going to search out here for a tire, and we have probably 3 to 4 different models of a tire. I'm going to use a tire with magic formula. If you guys have learned magic formula for tire in maybe in your vehicle dynamics subject, you must be knowing that what is a magic formula and how exactly we can model a tire. So let me zoom in a bit, and you can see there are 4 terminals of a tire, right? And because we want to make this as a four-wheeler, I'm going to copy this just by right-clicking on this, and I'm going to replicate it for uh, 2 more times so that I have 4 number of wheels, right? So now I have 4 number of wheels, and all these 4 number of wheels have probably similar kind of connections, right? So N is nothing but where you need to apply the normal force. A is nothing but an axle. H is nothing but a hub, and S stands for slip. If you want to apply some slip, you can apply to that port, right? So these are the blocks of a tire, and if I double click on this block, you will be able to see the help, and you will be able to learn also how this block is actually modeled, right? So what we have is how much load in newtons it can handle, what is a kind of a geometry in terms of rolling radius, what is a rolling resistance, and what are other parameters, right? So all those parameters are built in, and I'm keeping them as a default parameter. Now, what we need to do is over this four wheels, I need to zoom it out a bit, and I need to connect a vehicle body on this, right? So if I search for a vehicle body, we have so many other uh, options. I'm going to choose the first one, which is from Simscape Driveline, and this is a vehicle body. So it may not look like a vehicle body, but what you see here is an R and F. So the normal force for the rear wheels, the normal force for the front wheel, the H is a hub which we need to connect with the wheels or tires. V is a velocity, and these are the parameters. So if you double click on this, you can also learn about what is a vehicle body, right? And uh, what is a frontal area of the body, what is a drag coefficient, and what is the air density which is going to be experienced by the vehicle body. So here in a block diagram format, you can assign all the input values which are relevant to your vehicle, right? So probably you need to learn the theories behind how these blocks are modeled and how these blocks are actually to actually connect the vehicle body over this four wheels, and therefore let me connect this in. I'm going to consider these two blocks as a front wheel. Okay, I'm connecting this one with this. If you are making a wrong connection, the Simulink is not going to allow you to do so, right? So I'm going to consider these two as a rear wheels and these two as a front wheels. So I'm connecting the N over here. We can actually connect the hub of this part with this. We can connect the hub of this part with this one, and to any of the hub we can actually connect like this. Probably if you make all the connections, when you need to figure out where these connections are going, right? So you need to make it as simple as possible. So NR, NF, I have connected. The beta is nothing but the angle at which the vehicle body is moving. We can keep it as a constant. You can keep it as 0. The V is a velocity output. You can take it out from here. And the W is again a parameter which you can search out from here. And this is with reference to the center of the gravity, and uh, you need to figure out how much is the force required according to the mass which we are taking into the consideration, right? So here we are considering the vehicle body mass to be 1200 kg. In order to do a simulation, what you need to do, you need to consider the vehicle body mass along with the passengers and the driver mass as well, right? Now, what I'm going to do, I'm going to finish off all these connections, and I'm going to make this all stuff inside a subsystem, and then I'm going to create a vehicle body subsystem, right? So that my this 5 number of blocks are kept separately in a subsystem, right? So that's the first thing which you can do in order to easily uh, coordinate with your number of blocks. The other thing is, let me take you a simple gear, or this is a simple gear over here, where I need to connect the shaft of this gear as an input. I'm going to connect a DC motor over here, and I'm going to connect F block to the hub part, where we will be directly connecting this to the vehicle body, right? And this can be done through the vehicle body, through the hub, and through the front or rear axle, right? So here let's have a axle connected like this, A to A for the front wheel, and another A2A for the rear wheels, and let me connect this output with let's say the rear axle, so that this will become a rear wheel drive, or you can consider this as a front wheel as well, right? If you connect this F part over here to this axle, then it is going to become a front wheel. Guys, to just to inform you that how are the electric drives, right, or electric powertrain. So electric powertrains are available commercially in both the ways. They are front wheel also, some, and some are rear wheel driven as well, right? So here we are, let's say, considering a case where it's a rear wheel driven. Now what I need to connect with this, I need to decide a gear ratio, right? So here the number of teeth and the mashing losses and the viscous losses are also modeled, and the ratio here is 2, right? And the output shaft is going to rotate in the opposite direction of the input shaft, right? So if I keep the default options, and the next thing is, once the mechanical things are over, now I need to connect some inertia block as well over here. So let me connect the inertia block. The point of connection is on the top side. I need to rotate this block. And probably you can use Control R to rotate your block easily, right? So now I have connected some inertia, which is kilograms into meter per second square, or kilogram into meter square. And this inertia is nothing but the inertia of the vehicle, which is applicable to the shaft of the transmission system, right? Our transmission system is also very simple. It's just a gear ratio, right? So now let me come out of this and keep this system aside, and now let me search out for the electrical blocks, which is a DC motor, right? So I'm going to take a brush type DC motor. Now, let me zoom it a bit so that you can understand how does a DC motor will look like inside Simulink. So here what you see is a positive and negative connections, where we can connect battery or the controller output, motor controller output. And here we have something called R and the C, right? So it's a coupling between electrical system and the mechanical system, shown by these 3 dotted lines. So R and C is nothing but a mechanical system colored in the green, and the blue one is the electrical system. Now let me connect this. R is a rotating part which to this block. Now what you see is we have connected a DC motor to the input of this simple gear. Now where do I need to connect the C? So C is basically a casing, and we need to connect to a mechanical rotational reference, right?